All of chapter 1 is about solving the differential equation dy dt equals some function of y and t. But as we've seen, most of the time you simply can't solve it analytically. You can't write down a simple solution. Although, as a couple of the problems in the last section pointed out, if you could somehow guess a solution, it's pretty easy to verify if it's a solution, even if you can't solve it. If somebody gets lucky and guesses a solution, taking derivatives is real easy. It's taking antiderivatives that's much, much harder. So if you somehow somebody suspects that a solution has a certain form, you can simply plug it in and check. But usually you simply can't solve y prime equals f of t and y for most problems. However, it doesn't mean there's anything wrong with those problems you can't solve. You can solve them on the computer. And DE Tools, which is a software which comes with the book, has one app is HPG Solver, which shows the slope field, which is what section 3 is about. Now, what's the slope field? Well, if you have a differential equation dy dt equals f of t and y, what does that say? That says if you're at any point t and y, just plug into the right hand side and that'll tell you what the slope is. So basically at every point in the plane there's a little arrow that says if you ever come through this t and this y at this point, then your slope needs to be such and such. So if you ever come through our town, go that way. And well, since there's an infinite number of points, you can't plot the slope at every point, but with this DE Tools HPG solver, you can plot a lot of them. So for example, the default differential equation, you can put anything you want here, is y prime equals y minus t, which isn't separable, but it is linear. And show the field. What does this show? That at each point, for example, t equals 0, y equals 0, y minus t is 0 minus 0, which is 0. So it says if you ever go through the point 0, 0, your slope should be 0 minus 0, which is 0, and that's what it is. On the other hand, if you go through the point, this looks like about t equals 0, y equals 1, then the slope should be y equals 1 minus t equals 0. 1 minus 0 is 1, and that looks like about a 45-degree angle. And if you go over here to t equals 1, y equals 1 approximately, that slope should be 1 minus 1, which is 0. So at every point, or a lot of the points in the plane, they've drawn an arrow showing the slope, and that's simply the value of y minus t at that point t and that y. So basically, even if you can't solve the differential equation, the computer can. It just follows the arrows, which, by the way, makes you suspect that for a given differential equation and a given initial condition, there's one and only one solution. You just, in fact, you can, with the HPG Tools thing, you can click on it and it will show, it will follow the arrows. If you start, for example, what am I starting at here? Approximately t equals 0, y equals 1. It actually goes forward and backwards. We're not really so interested in going backwards, but forwards the solution looks like that. If you start at 0, 0, solution going forward goes like that. It's just simply following the arrows. So it looks like you start at any point. There's one and only one thing it can do. It just follows the arrows, and so there should be a unique solution. And we'll see in section 5 that that's almost true, unless there's something really weird about the function f of t and y. That will be true, that with a given initial condition, there's one and only one solution. There's a lot of different solutions depending on what your initial condition is, see, but once you pin down the initial condition, there's only one solution, and you can just follow the arrows, or at least the computer can. Now, problem 2 says plot the slope field for y prime equals t squared plus 1. And it's pretty hard to do by hand, so let's do it using DE Tools. And there it is. And notice that the right-hand side depends only on t. That means that if you change y, go up and down, the slope doesn't change. So for a given value of t, for example, t equals 0, the slope is 0 plus 1. It doesn't matter what y is, so the slope's the same going up and down. different value of t, you get a different solution, but if you change y up and down, it doesn't change. So if the right-hand side is a function of t only, then you can identify that by looking at the slope field. It varies, it doesn't change with y. And furthermore, you know, to solve this, you're just going to get the antiderivative of t squared plus 1 plus an arbitrary constant. So different initial conditions just change it by a constant. So for example, if I try two different initial values, this curve is really just this one displaced upwards by that amount. It doesn't look like it because it's an optical illusion here, but the distance between here and here is the same as the distance between here and here, and so forth. In other words, this is the same as this, except different plus c. And problem 3 says y prime equals 1 minus 2y. This time the slope field is a function of y only. That means that for a given y, the slope is the same no matter what t is. So if you go left and right, slope doesn't change. For example, here, when y is 0, the slope is 1 minus 2 times y, which is 0, and doesn't matter what t is. So you go left or right, slope is still 1. Go up here, the slope is negative. Y is about 2, I guess. So 1 minus 4 is minus 3 or so. So the slope is about minus 3. It doesn't matter what t is. You go backward, forward, it's the same. So you could tell just by looking at this slope field that the right-hand side is a function of y only. In other words, that it's an autonomous problem. Notice that when y is 1/2, the slope is 0 no matter what t is. So you can see that the solution is approaching 1/2 there. It can't go past 1/2 because it ever gets to 1/2, the slope will be 0 forever. So it just converges to 1/2. You start above, it converges down to 1/2. Now let's do a problem where the slope field depends on t and y. And that would be problem 6, y prime equals y plus t plus 1. And that's what that field looks like. The book problems, it's pretty hard for you to draw this by hand, so basically we'll rely on DE tools to show you what these slope fields look like, but you may have problems like problem 16, which we'll get to in just a second, where you are given the slope field and you're supposed to identify it. So you can start at any point here and see what the solution looks like going forwards or backwards. So basically it's a numerical solution. I don't know what, well actually it says it's using a Runge-Kutta method, so it's probably using something similar to that MATLAB ODE 45 routine. More accurate than what we're going to study in the next section, which is Euler's method, but Euler's method will work also, just not quite as accurate. So basically you just follow the arrows. At every point there's a slope field saying if you ever come here, go this way. So just follow the arrows and that's the solution. And if you start at any point, it's going to be one and only one way to go, at least normally. So it's not reasonable to give you an equation and ask you to draw the slope field. That's the job for a computer. And it's not even reasonable to give you the slope field and say what's the equation. But a matching problem like this will work. For example, it shows the slope field and you're supposed to choose one of these 8, which could be the equation that slope field represents. And there are various ways of narrowing it down here, but what I would do is first say, is this slope field a function of y only or t only, or both? And you can see that it's, if you can see this in the video, the slope field depends on y only, because for any y as you go left and right, the slope doesn't change. It does change as you go up and down with y, but not with t. So that eliminates all except the first three, because all the other five have t in them. So it's got to be one of the first three. And you can notice that looks like the slope is 0 when y is 0 or minus 1. So we're looking for a right-hand side which is 0 when y is 0 or minus 1, and that would be 1 and 3. If you factor out a y here, this is y times minus 1, so that would be 0 when y is 0 or 1. These two are 0 when y is 0 or minus 1. Factor out a y here, you got y times y plus 1. Factor out a y squared, you got y squared times y plus 1. So they both have the right values of y, which is 0 slope. So it's either 1 or 3, and at that point you probably just want to pick a value of y. And for example, if y is 1, well, that won't work because they both give 2. Says y is minus 2. This gives 4. Minus 2 would be 2. This gives minus 8 plus 4. So this is negative and this one's positive. So it looks like it's negative. So it must be 3. So just pick a point. I picked minus 2, and the slope, looking at the field, it's negative. When y is minus 2, that would give a positive number, that would give a negative number, so it must be 3. And you could do something similar to b. It looks like as a function of t only. As you go up and down, the slope doesn't change. Left and right it does change, so it's a function of t only. And that narrows it down to these two here. And you can see that it looks like that when t is about plus and minus 1.5, the slope is 0. Well, these two both give slope at 0 of t equals, when t is square root of 2, so they both fit the bill. So you just have to pick a point. For example, t equals 0, and this one predicts the slope should be positive. This one predicts it should be negative. It's negative, therefore it must be number 8. The other two are a little harder because they're both functions of t and y, but I'll let you do those. So that's the kind of problem that you might expect from this section on the test. Here is an old test. I draw a slope field using DE tools. It's very hard to see here. I don't know if you can see this in the video at all, but if you look at it, you can see that the slope, if you look at it real closely, you can see the slope doesn't depend on t. As you go left and right, the slope's the same, only depends on y. And it looks like the slope is 0 at about y equals 4 and y equals minus 1. And the test problem is a multiple choice. It says which one of these four could be the one shown on the next page, which it's easier to see in person than it is on this video, I'm afraid. So, but we saw that it's right-hand side's a function of p only. That rules out 4. And it's 0 at p equals minus 1 and 4. That rules out 1 because that's 0 at 1 and 4. So it has to be either 2 or 3. And I'm not sure how I determined that it's 3. I just plugged in p equals 0 probably and saw that it was positive instead of negative. Pretty much like problem 16 that we just looked at.